Happy snow day, students. Let's do some math. Hello to my Algebra 2 students. Today we're going to be practicing solving for a standard form given 3 different points, -7, 13, -1, 1, and 2, 4. From there we're going to be converting to vertex form, sketching a graph, and then solving for the zeros. Follow along, do the problem ahead of me, pause it, and then once you've gotten through maybe a few steps, keep watching the video to check to see that your understanding is on point. So first thing I want to do is start by thinking out, if we're solving for a standard form first, what does standard form look like? Y equals A, which is a coefficient, x squared plus B, coefficient, x plus c. Standard form in this case, we are specifically talking about a quadratic function for those watching that do not know specifically math class. So the first thing I want to start doing is plugging in my points. If I were to put in -7, 13 into this, it would be a -7 going in for this x, and putting a y equals 13 in for this y here. So 13 equals a times -7 squared plus b times -7 plus c. From there, I'm going to simplify and I'll have my first new equation. I'm going to give this equation here a letter. I'm going to call this J so I can refer to it later on when I'm going about doing things. I'm going to circle it. I would recommend if you were doing this on a test or quiz, label it with some kind of new letter and then you can reference it later and it's easier for me to follow your work. From here, I want to create a second one. Done. There's my second equation. 1 equals a minus, I'm just going to get rid of that 1, so it's a minus b plus c equals 1. I'm going to use my third points. I'm going to use m instead of l in this case just because m is a little bit more recognizable, can't be confused with a 1 versus L, JK, L. So I have my new 3 equations, and what I'm going to do is I'm going to use elimination to solve for the 3 of them. From here, we want to take J, K, and M and eliminate one from the other so that we can start narrowing it down. So since C is all alone, there's no coefficient on each of the C's, what I'm going to do is I'm going to subtract K from J and then I'm going to subtract K from M to get new equations. So I'm going to start with J minus K. What I'm going to do is, as I write this down, since I'm going to be subtracting K, I'm going to switch the signs on each of them. So that's a -1, it's going to be a -A, it's going to be a +B, and it's going to be a -C. I didn't finish writing the positive because I would have to erase it. So I can now put these two together. So I'm really going to be subtracting, but I'm going to be adding a negative. I've multiplied the whole thing by -1, so now I can add it, as I think that's a little bit easier. Some people want to subtract, that's fine. It's up to your own preference. And I'm going to label this equation P. Next, I'm going to subtract K from M. So again, I'm going to flip the signs as I write them. I'm going to be doing the same thing over here, so I can just copy this over here. You always want to do anything you can do to help yourself out to make things simpler. Whoops. Should be a B. I'm going to call this equation Q to organize some things. Next, now that I have P and Q, these are down to 2 variables, A and B. These are down to 2 variables, A and B. I'm going to go ahead and eliminate over here as well. I'm going to add P plus 2Q. What that'll do is, because I'll be multiplying Q times 2, this will be 6B. Since this is -6B, the B's will cancel out and I'll be left with A on its own with a number. So again, as I write these down, I want to multiply each of them by 2. I don't know that off the top of my head. I know that this is 6 times 9. I know that this is 3 times 6, so it's going to be 3 over 9 or 1 over 3. So A equals 1/3. Now that I have this, I'm going to plug this back into one of my 2 unknown equations. So I might even write it like Q. I'm going to substitute in A equals 1/3. Just to organize my information and show my work effectively and communicate it to the teacher or whoever's checking. Or if I were looking back in my work, that I can tell exactly what I'm doing here. So I'm using equation Q and I'm putting in a equals 1/3 for a. Alright, so I've now come to 2/3 equals b. I can now substitute both of these into one of my original equations. I think I'm going to do this into k. So I got k up here, 1 equals a minus b plus c. So I can write k, and then put in a and b. Alright, and I now have c equals 4/3. So I can write in standard form y equals a is 1/3 x squared, b is 2/3 plus 2/3 x plus 4/3. This is standard form. From there, we're now going to be converting to vertex form. So the first thing I want to do is deal with this a. So a is 1/3. If I factor out a 1/3 from each of these numbers, I'll end up with this right here. From here, I want to complete the square. Because I know that this will be split into a 1x and a 1x, I know this number multiplied times itself is going to be a 1. If I add 1 and subtract 1, and then keep this 4, this will be like adding 0, which I can do. This right here is going to do the reverse of FOIL, the inverse of FOIL, x plus 1 squared. From there, I'm going to simplify this so both of these came down here. And finally, I want to redistribute that 1/3 to both these terms. Now that I have this in vertex form, it'll be really easy to sketch this out. I know that the x-coordinate of my vertex is going to be -1, and my y is going to be +1. We know definitely works, because we already know that -1, 1 is going to be in here. And we know since this is a 1/3, it's going to be a bit wider than normal, so it's going to look something like this. Which also makes sense because we have a 2, 4 and a -3, 17. So 2, 4, 1, 2, 3, 1, 2, 3, 4. And up here will be our -7, 13. Lastly, we're going to solve for the zeros. Now looking at this picture, we can tell it does not actually come in contact with the x-axis, therefore it's going to have what kind of root? Yes, imaginary roots. Now from vertex form, it'll be really easy to come up with my zeros. So we're going to do something similar to the proof of the quadratic equation. I'm going to set y equal to 0. From there, I want to get x on its own. So start with subtracting 1. And just multiply the whole thing by 3. That'll fix that. Square root both sides. End up with a plus or minus over here. So I have plus or minus the square root of -3 equals x plus 1. Subtract 1 from each side, and I end up with -1. Plus or minus the square root of -3 equals x. And finally, I'm going to factor out that square root of -1. So it's -1 plus or minus I root 3 equals x. And those are my imaginary zeros. Hope this is useful to my Algebra 2 students, and for any other math students that watch this, thank you for watching. Let me know in the comments what are the things you'd like to see me do. Let me know what would you like me to do to make videos like this better so that people are finding them to be more useful. Go to Khan Academy. If you don't like what I do, I'm sure Khan Academy does a much better job as they do it professionally. I just make YouTube videos on the side. I'm not a professional YouTuber. So thank you for watching. Leave it a like if you want more things and you love to see this channel grow and you love to see me make more things. Thank you for watching. Feel free to subscribe. Check out my other videos if you're interested in things other than math that I talk about and teach about. Stay weird.